So what kind of triangle do we have in this first question? Isosceles. Well, we know we have two congruent sides. So how many congruent angles do we have? Two of them. We need to locate them. The congruent sides are across from the congruent angles. So what angle is across from NL? What angle is across from NL? Angle M. So M is going to be one of our congruent angles. And then what angle is across from LM? Angle N. So if those two angles are the congruent angles, what can I do with them? Set them equal to each other. 2x equals x plus 30. Subtract x, and x is 30. It's okay. It says M angle M. What does this little m mean? Measure. So our answer will look like a number, right? The measure of angle M currently is x plus 30. We know x is 30. So what is the measure of angle M? 60 degrees. Which technically means, what kind of triangle was this? It's not just isosceles. Yeah, equilateral, equiangular. We figured out. Because these two would be 60, which meant the third one had nothing else but to be 60 as well. This next question, the only number we have is 28. How is that helpful to me to find the measure of angle K?
You can do vertical angles.
We could do vertical angles. What do we know about vertical angles?
Congruent.
They're congruent. Then you have 28 degrees inside of this triangle. This triangle is isosceles. It's got two congruent sides. So which two angles will be congruent? G and K. So G is across from this congruent side, and K is across from that congruent side. So what do I do to find angle G and angle K?
Subtract 28 from 180 and divide by 2.
Correct. So subtract 28, figure out how many degrees we have left to split. We'll have 152 left to split evenly between G and K, which means each of those angles equals 76. So the measure of angle K is 76 degrees. So this is from 5.4. So this chapter is called Congruent Triangles. There are 5 theorems that prove that triangles are congruent. You only learn about this in geometry. It's one of the only things that we do in this class that you don't repeat from Algebra 1 or Algebra 2. 5.3 is about proving triangle congruence. Does everyone see how it says SAS? We're all educated folk. We do not say SAS. We don't say SAS. These letters stand for something. They're on the page here. They stand for side, angle, side. So this first theorem is called side, angle, side, and we will talk about it. The first thing we're going to do is fill in the blank. It says congruent figures, which is at the top of 5.3. All right, congruent figures. They're geometric figures that have the same shape and size. They're geometric figures that have the same shape and size. Geometric figures that have the same shape and size on the top of your paper. So we're in 5.3, geometric figures that have the same shape and size. So we're all looking at this piece of notebook paper, all right, ready? This is not necessarily a triangle, but it has the same property. These two pieces of notebook paper are congruent, yes? They have the same lengths, they're both rectangles, okay? Even if I move one way over here, are they still congruent? Yes, even if I flip it upside down, are they still congruent? Even if I rotate it, are they still congruent? Even if I put it behind my back, are they still congruent? Yes. So we're going to talk about triangles, and these triangles have been moved apart and possibly flipped or rotated, and we're going to decide if they're congruent or not. All right? They're moved via, it's called rigid motion. It's just we can call it a motion that preserves length and angle measure. You can call it a motion instead of transformation. It is a motion that preserves length and angle measure. Preserves length and angle measure. So it literally means one was, slid over, flipped, turned, but not made larger or smaller. It's the same shape. So in order for a triangle, which is the next blank, in order for two triangles to be congruent, all the sides and angles must be congruent. So in order for two triangles, next blank, to be congruent, all the sides and angles must be congruent. So how many pieces of information are there in a triangle if you count sides and angles? How many sides are there?
3.
How many angles are there?
3.
So how much total?
6.
6 pieces of information, right? So that would be a lot to have in a triangle, a lot of information. You don't need that much to figure out if they're congruent or not. So that is the next blank. You don't need to know every side and angle to know the triangles are congruent. You don't need to know every side and angle to know the triangles are congruent. And then you're going to highlight that sentence. That's the whole purpose of this section. You don't need to know every side and angle to know the triangles are congruent. And then you're going to highlight it. It brings us to our first theorem that proves triangles are congruent. It's called side angle side. Go ahead and fill that in. It says Theorem 5.5. It's called side angle side. So Theorem 5.5 is side angle side. We're going to read it together, and then I'll explain it to you. So if two sides, so your first blank is 2. If two sides and the included angle, if two sides and the included angle of one triangle are congruent to the two sides and included angle of a second triangle, then the two triangles are congruent. That was a lot, but it's not a lot. Go ahead and highlight two sides and the included angle. Two sides and the included angle. And before I even explain that, go ahead and write down what included means. Included means between. That's it. So if you have two sides and an angle in between them, marked congruent to two sides and an angle in between them, then that is enough to prove that you have two congruent triangles. Two sides and an angle in between. So we have this picture. You're going to fill in yours. If PQ is congruent to WX, go ahead and fill it into the blank. If side PQ, if PQ, well, you're going to fill in this via this triangle. So PQ is congruent to WX. And then you want to make sure you mark it on the triangles themselves. So we got PQ marked congruent to WX. Angle Q is congruent to angle X. And then we need another side. So let's talk about it. Let's just try to think. You need two sides and an included angle. What does included mean? In between. So we have an angle and we have one of our sides. What other side would need to be congruent for my angle to be between the two sides?
W, Y, P, S.
So you're saying my angle would be between these two sides.
Oh, Q.
It'd be QS. And then if it's QS on the first triangle, what would have to be on the second? XY. So QS has to be congruent to XY. So included means like literally wedged in between these two sides. That is side angle side. So if you have a side congruent to a side, an in-between angle congruent to an in-between angle, and a side congruent to a side, then that is enough to prove that triangle PQS is congruent to triangle WXY, which I believe is the last blank for this page. So PQS is congruent to triangle WXY. So So here's what's going to happen. You don't have to write this down yet. I'm just trying to show you what situation we'll be put in. You'll be seeing triangles, and it'll say, is there enough information to prove the triangles are congruent? Does everyone see how things are marked congruent here? We've got, what do tick marks mean? Sides are congruent. What do arcs mean? Angles are congruent. We can't make things up. We can't be like, well, this side looks like it's the same length as this side. That is not how this section works. It's either there or it is not. But there are two things that you will see that are not marked congruent, but that we understand are congruent. Okay? And one of them, it's understood. It's called the reflexive property. It is on your paper. It says, remember the blank property? It is the reflexive property. We're still on the first page. Reflexive property. The reflexive property says that something is congruent to itself. Okay? Look at these two triangles. We've got things marked congruent. We've got a side congruent to a side. We've got another side congruent to another side. We've got an angle marked congruent to an angle. But does everyone see this side in the middle? They share this side, correct? So I need you to think for a second in real life. Look at this wall. Miss Dix and I share. Everyone sees it? I don't know the length of the wall, but let's say it's 40 feet on my side. What's the length on her side then? 40 feet, because it is the same wall, right? So these two triangles share this side. We agree? So whatever the length of whatever the length of DB on the top triangle is, it's the same length as DB on the bottom triangle, right? Because it's the same side. Are we okay with this? It's congruent to itself? Okay. Is it marked congruent? No. But do we know that if they share that side, it is congruent to itself? Yes. So this is something, I usually write an S. Some people write tick marks, it doesn't matter. But you need to look for a side that they share. It will be one of the congruent sides that you'll have. Okay? The second thing, I would not turn the page yet. The second thing you'll want to look for are some angles. Let's say we had these two triangles. What relationship do these two angles have? They're vertical. I'm going to tell you right now, vertical angles will not be marked. But what do we know about vertical angles? They're congruent to each other. So I would write down that vertical angles are congruent. Those are the two things that will not be labeled on your paper, but that you can label yourself. You can look for a side they share, and you can look for vertical angles. Because they will never mark either of those. But you can, because it is understood. Okay? Now, we're going to find this section. Because we're going to go from easy to medium to, only makes sense. So go ahead and find this section. We're actually not going to go in the order they are in your paper either. I learned. We're going to decide if side angle side theorem can be used to prove the triangles are congruent. So let's start. Go ahead and highlight the top triangle. We are comparing one triangle to the other. Comparing one triangle to the other. So what do we have marked congruent in this top triangle? We got an angle marked congruent to an angle. So I normally write the letter A next to it. It's helpful. And then what else do we have in this top triangle?
The side.
A side congruent to a side. That's what we have marked congruent in the top triangle. Is there anything else that is understood congruent in this picture?
Yes.
They share a side, yes? So the length of the side in the top triangle is the same length as that side in the bottom triangle, yes?
Yes.
So go ahead and mark. Put an S there. So, do we have side, angle, side? Is my angle between my two sides? Here are my two sides. Is my angle between the two sides?
Yes.
Is it touching both sides?
No.
So is it between them? This is a no. It is not it's not side, angle, side. The angle would have had to be between your two sides. I just highlighted in purple. This is where the angle should have been, but it was not. This actually is a different theorem that doesn't exist, and it's called side-side angle. It doesn't exist. So a lot of students look at this section and they're like, we're doing random configurations of the letters A and S. You will never spell donkey. Do you understand?
I don't get it.
Oh, she means
Because there's another name for donkey.
The other word for donkey? You know. That's not a theorem. The biblical name for a donkey. He's lost. It's fine. It's fine. It is not a theorem, and it's not because it's just a taboo word nowadays. I'll show you tomorrow in the video why. Like, I'll show you a picture. It's not enough information in the angles to figure out if the triangles are congruent. So if you ever find yourself writing it down and you're like, I don't know if I'm allowed to write this on this paper, you're not, because it's not a theorem. Okay? So angle side side, side side angle is not a thing. Okay? Just so you know. I'm going to move to this one, which I think is your third picture. Okay, so I'm going to compare the triangle on the left to the triangle on the right. We want to mark what we have congruent. So what are some things we see that are congruent? We got a side, congruent to a side. We're getting there. What else is marked congruent? Another side, congruent to another side. Is there anything understood? Vertical angles. So is this side angle side? Yes. My angle is between my two sides. So this is enough to prove the triangles are congruent by side angle side. We'll go back to this one. I'll tell you why we didn't do it second here in a minute. I'm going to compare the top triangle to the triangle on the bottom. So we got an angle marked congruent to an angle. What else do we have?
Another angle.
We have another angle. Is there anything understood? The side they share. So do we have two sides and an angle in between them marked congruent? No. We do not. So no. I'm going to tell you, you're going to learn here in a second, there is a theorem called angle side angle. So it's not that they're not congruent. It just says, is side angle side the reason they're congruent or not? No, it's not side angle side. We did this one in a different order because I didn't want two no's in order. Just so you, if you cared why we skipped around. We're going to do the last one. I'm going to compare the top triangle to the triangle on the bottom. So what do we have marked congruent? We got side, congruent to a side, and then we have an angle, congruent to an angle, and then do we have anything understood? The side they share. So we have two sides, and an angle is the angle in between them. Yes, it is in between them. So this is side angle side, yes. We'll go back to the page before really quick. Not to do that, to do this. We're going to name the included angle between the pair of sides that were given. So JK, and then they gave us KL. We want to name the angle in between them. So what will the vertex of this angle be? Which letter is the vertex of the included angle? K. Can I name it just angle K, though?
No.
No. So what would I name this angle in specific?
K.
Can't say K because there's two Ks. JKL. Very good. Remember that your vertex needs to go in the middle. So JKL. JKL. You could have said LKJ. Both are correct. Good job. We'll do one more of those. It says LP. And then LK. So what's the vertex? Just asking for the vertex for now. What is the vertex of the included angle?
L.
L. So then how would I name that angle?
PLK.
PLK or KLP, either one. PLK, KLP. Both are correct. Okay. Questions about included angle? Okay. All right, now we move forward again. Pretty sure that's the last time we bounce back and forth. So state what additional information is required in order to know the triangles are congruent for the reason given. So if something is missing, we have to state what else we need. So we want to prove side angle side. So let's look at what we do have. Do we have a side marked congruent to a side? Yes, we got sides. Do we have an angle congruent to an angle? Yes. Do we have another side congruent to another side? No. So we need to name two sides that should be congruent to have side angle side. So what side would need to be congruent on this first triangle? CA. So CA, if you just draw the lines, you're not actually naming the answer. This is just helpful, the picture. But CA is congruent to, this part is our answer. CA is congruent to LJ. The order of your letters does matter, keep in mind. Oop. There we go. All right, and for the second one, again, we're trying to prove side angle side. Do we have a side congruent to a side?
No.
We don't?
Oh, we do. Oh, yeah.
The side they share. Yeah, you're good. And then do we have an angle congruent to an angle? Yes. So then we are just missing another side, right? So what side would have to be marked congruent in order to have my angle in between? WV is one of them. And close. So if I said WV, I have to say KX. Good. So it couldn't have been WV because then my angle wouldn't have been between my two sides. That's why we picked WV and XV. I think that's it on that one, right? So let's do 5.6. All right, so we just did side angle side, yes? So if you had to guess about what ASA stands for, what do you think?
Angle
Side, angle. So where do you think the side has to be?
In the middle.
In the middle between the two angles. Good. And then AAS is angle side. So guess where the side is not? Is not in the middle. Okay, so that's it. And then we will be finished for the day. So we're on the second page. The first page is a bunch of review, which we'll have time to do at a later date. So on the second page, that's the worksheet.
No.
This is the... Yeah. Has everyone found this? Go ahead and fill in. This is called angle, side, angle. Angle, side, angle. Kobe. Can't complain about your geometry grades and fall asleep. Angle, side, angle. And then you're going to highlight since we don't have to fill in the blank. So this time, we're looking for two angles and an included side. Go ahead and highlight. We're looking for two angles and an included side. Two angles and an included side. So we got angle A is congruent to
Angle D.
angle D. AC is congruent to DF. And then angle C is congruent to angle F. So this is angle, side, angle. Triangle ABC would then be congruent to triangle DEF. Good. So now we're just going to practice finding it or not finding it, one or the other. We have this below. It says in the diagram, we're going to read. It says AB. What does this symbol mean? Perpendicular. What does perpendicular mean?
They intersect in form 90.
They intersect form 90. So it says AB and AD. Do they intersect in form 90?
Yeah.
They do?
No.
They do. No, it wasn't a question mark. They do. You're good. I'm just making sure all of our information is there. Sometimes the information is in the directions and not in the picture. Then it says DE is perpendicular to AD. Do we agree? DE is perpendicular to AD. Do they intersect to form a right angle? They sure do. And then last, it says AC is congruent to DC. Do we agree?
Yeah.
Yes. Right? They got those. So all the information is there. It says prove. We're going to cross that out because that means something in geometry that we do not want to do right now. We're not proving. All we're going to do is decide what makes these triangles congruent. I'm going to compare the triangle on the left to the triangle on the right. What do I have marked congruent?
AC and DC.
I have a side marked congruent to a side. What else do I have congruent?
Oh, the whole triangle. Both triangles.
Well, we're trying to prove them congruent.
Oh, right.
What sides or angles do we have congruent?
Angle A. Oh, yeah.
Angle A is congruent to angle D. Is there anything else? Anything that's not marked? No. Remember, you can mark one of two things. Reflexive sides or vertical angles. Do we have either of those? We got vertical angles. Correct. So those are the only two things you can just poof out of nowhere. Because they do exist and they are congruent. So, are these two triangles congruent? Yes, by what theorem? Angle, side, angle. Remember, we are educated folk. We say angle, side, angle. Questions on this one? Okay. So then the last one we learned today is angle, angle, side. So go ahead and write in angle, angle, side. Angle, angle, side. Then you can highlight. That's two angles and a non-included side. Two angles and a non-included side. Two angles and a non-included side. All right, so in this case, the side is not in between. So we have angle A marked congruent to angle D. Angle C marked congruent to angle F. Then we have two sides, right? What side is marked congruent in the first triangle? BC. BC is congruent to EF. And then last triangle ABC is congruent to triangle DEF. Good. This is the last one we'll learn today. The side is not in between them. That's all. Okay, so you have two angles and a random side marked congruent. This one looks hard. Again, we're going to cross out the word prove because we're not proving today. If you ever ask your parents what a proof is, that's what it's asking you to do. But anyways, we're trying to decide if these are congruent or how they're congruent. Pictures are best, right? We're going to go ahead and draw two pictures. So we got triangle ABC. We're trying to show it's congruent to triangle DEF. Try to make them look the same to the best of your ability. Make sure your letters correspond. A and D, B and E, all that. Are we okay with our pictures? You're not okay with your picture? We just read this. He's just coughing. He's fine. Mike, all we did was draw ABC because it said we're proving ABC is congruent to DEF.
No, you said a picture.
Yeah, are we okay with the picture? It's just a triangle.
No, I just got my picture messed up.
Oh, okay. I was asking if you knew how we drew it. But you good?
Yeah, it's not funny no more.
No, you was lost. You know how to draw two triangles.
All right, let's mark the angles congruent. We're moving on. Angle A is congruent to angle D.
Nice.
So go ahead and mark them congruent. You mark them congruent with an arc. And then C is congruent to F. So I would mark it with two arcs so you know C and F go together.
Nice.
And then last you have BC is congruent to EF. Tick marks. So I'd put 1 and 1.
You have to do one, or
You can do 2. You can do as many as you want as long as they're the same amount. All right, so we have two angles and a pair of sides, yes?
Yeah.
So we need to decide, is it angle side angle or angle angle side? Is the side in between, like angle side angle, or not in between, like angle angle side? It's not in between. It's angle angle side. Boom. Wonderful. When you're ready. Now we just practice all of it. This did not print well. I would use your pencil if I were you, and I will show you. This is a triangle. You'll probably have to redraw it. It's just triangles, right? Like, it's like non-existent. You just got two triangles. So everyone drew it? Draw it, drew it.
What are we drawing?
Do you see how my picture has lines and your picture has none? You see how that worked? It just printed much darker than what it was. You know what I mean? All right. All right, so what do we have marked congruent?
The two angles.
We got angles. What else do we have?
Sides.
Sides. Is there anything not marked congruent that we understand are congruent? Vertical angles. So we have two angles and a side. Is it angle, side, angle, or angle, angle, side? Angle, angle, side. The side is not in between. So it is angle, angle, side. Letter B, what's marked congruent?
Angles.
Angles. Three of them. Dude, is angle, angle, angle a theorem that we have learned today? No, I'm going to tell you it's not a theorem in general. It's a no. Because it says, can the triangles be proven congruent? It's a no. There's only so many ways for three numbers to add up to 180, right? Think about all the different types of triangles in the world. Think about equiangular triangles. How many degrees are all those angles?
60.
60, 60, 60, right? All of you in your project, not all of you. You might not have picked the question, but equiangular triangles are not all the same like length, right? It's just a good example of angle, angle, angle is not a thing, and neither is side, side, angle. This last one is a weird looking staircase. So what do we have marked congruent? We've got an angle. I know it's super small on your paper. We got the side they share. Then what else? Another angle. So is the side in between like angle, side, angle?
Yes. No. Oh, yes, it is.
Yes.
It is in between. So this is angle, side, angle. Nice. Good. We'll do two of these and then I'll have you start something on your whiteboard. State if the two triangles are congruent. What do we have marked congruent in each of these triangles? We got two angles, and then do we have a side? The side they share. Is it angle, angle, side, or angle, side, angle? Angle, side, angle. And then let's do number 3. Does it look like number 3 on yours? Yes. All right. What do we have marked congruent?
Angle.
An angle, and then a side. So, is there anything not marked congruent that we can understand to be congruent? Vertical angles. So, is it angle, side, angle, or angle, angle, side? Angle, angle, side. The side is not in between. Good. I would take out a whiteboard and a marker really quick. You're going to practice. So, you can write the number and then tell me what theorem it is. You go at your own pace. Just show me your answer. Please don't do all 7 all at once. Just do 1. Show me your answer. Erase it. 2. Show me your answer. Erase it. All right, so you're answering number 1. Do you see a side marked congruent? That's better. Where are the sides coming from? Good. You're good. Good. Where's the side coming from? Where's the side coming from? Apparently.
Yeah.
Where is this? Guys, what side is marked congruent in this picture? Where?
I thought this is like
I just
90 right here.
Oh, yeah,
You can see that, you know?
that's not a side.
That's not a side. That's a right
That's an
angle.
angle. That's an angle.
So number 1, you have 3 angles marked congruent to 3 angles. Is that a theorem?
Oh no.
So this is not congruent.
Oh, some of these could be no.
Yeah. Well,
I
didn't
thought
we?
I thought they had the.
No. Determine if they are congruent. You are not correct. You are correct, though. Good, good. Not quite.
Excuse me. We're still a lot from each other.
Y'all need to write numbers, because I don't know what... I'm going to assume you're on number 2. That's correct for number 2. That's good. Yes. No. Not quite.
No.
It's good. Second one is good. Fourth one's good. Can you do one at a time? Not quite. That's good. That's good. That's good. Is that a 7 or a 2?
2.
Okay, that's good. That's better. That's better. Not quite. Not quite.
No.
Not quite.
I got it right.
Better is correct. No. The second one, you had a side, and an angle. Was the angle in between? Yes, it was side, angle, side. So I think most people are on 3 or beyond. Not quite.
Oh.
Yes. Did you not change your number? I feel like you just answered number 3. Not quite.
I did not change my number.
Correct. Not quite. Yes, yes. I didn't see your answer. Not quite. Not quite. Not quite.
Up here.
Yes. Not quite. Not quite.
Oh.
Yes, sorry. Everyone is on very different questions. That's good. Not quite. That's good. That's good. That's good. All right, pause for a second. I'm going to answer number 3. Number 3, you got an angle marked congruent to an angle congruent to an angle, and then a side they share. Is it angle, side, angle, or angle, angle, side? Angle, angle, side. The side is not in between the 2 angles. Go ahead and move on to number 4 if you haven't already. That's good. No. Yes. No. Yes. Yes. No. Yes. Yes. I don't know what number that is. No. That's better. No. Yes. Yes. Number 4 is hard? Yes. No. Yes. Yes. I'm going to answer number 4. Most of you have already moved on. It is side, angle, side. Has everyone moved on from... It's side, angle, side, because you got a side congruent to a side, an angle congruent to an angle, and a side to a side. So side, angle, side. Go ahead and move on to number 5. Not quite. That's good. That's good. No. Yes. No. No. Yes. No. There's not 2 sides. Yes. No. Yes. All right, number 5. What's marked congruent? Angles, right? We got 2 angles. What else is understood?
Side.
Is the side in the middle of them?
Yes.
Yes, so that is angle, side, angle. Number 6. That's good. What is not in this picture that we can draw? The vertical angles, right? So we have an angle, and a side. Is the side between the 2 angles? Is it on the same side as the 2 angles? It is not. So it is not between them. Between means literally dead in the middle of them. It is not. It is opposite of one of them. So this is not angle, side, angle. It is angle, angle, side. The side would have to be in between them on the same side as them. So that one is not it. That's good. Number 7. I think I told a bunch of people yes, so it's wrong. So let's talk about number 7. It's a trick question. You got a side. You're not stupid. Congruent to a side. Are they in the same spot?
Yes.
No.
No.
Okay, let's keep going. Then you have an angle congruent to an angle. And you have a side. So in the top, you have side, angle, side. The angle is between the 2 sides, yes?
Yes.
In the bottom, here's your side, here's your side. Is your angle between the 2 sides?
No.
So is it side, angle, side?
No.
No, this is a trick question. That one was a no.
So it's no.
It's a no. That's 7.
See, I know I got it right.
I'm sorry. All right, you're going to do this one. We're not done. What additional information is required in order to know side angle side? So you're missing something. You have to tell me what has to be congruent to have side angle side. You got to, no, that's already understood. You have to tell me what in specific that's already marked congruent. That is already understood. Look back at those are already understood. Look back at our notes, y'all. We did this in 5.5. So look at what we do have. Let's do number 1 together. What do we have marked congruent? Sides. What else is congruent in this picture? Vertical angles. Stop. Don't write vertical angles. It's not going to be an answer ever. What are we missing? Another side. You can't just say we're missing a side. You have to tell me what 2 sides have to be congruent in order to have side angle side. So you write it on your paper. Which 2 angles have to be congruent to have side angle side? So which 2 angles? Those are already marked congruent. Sorry, which 2 sides have to be marked congruent? We have a side and we have an angle. So what other side has to be marked congruent? That's an angle.
You said angle, right? Oh, you said side.
Y'all keep saying this one. If these 2 were the sides, would my angle be between my 2 sides?
Oh, I had it
No.
the first time.
You did not have it the first time.
No. I erased it before I showed you. Am I wrong?
I'm going to tell you the answer. Because,
Oh, did you?
no, you got it right.
I told you.
You did not get it right. Why do you have one thing named? What does that have to be congruent to? So show me on the picture, what needs to be marked congruent on this first picture to have side angle side? JI. So why didn't we write JI? JI has to be congruent to something else on my second picture. EI. That's the answer.
I had it when you reset. You know we're
I know.
together now.
You're going to try the second. What is missing? You write what has to be congruent in order to have side angle side. Something is missing. You need to tell me what needs to be congruent to have side angle side. So look at what you have. Figure out what you do not have. We have side. You're correct. You're half correct. Why are you saying it's congruent itself? Thank you. Almost. One of them is right, one is wrong. No. You have side, angle, side. No. Okay, sorry. Yep. So, Trey, we have a side congruent to a side, yes? We have a side congruent to a side. So, of side, angle, side, we have the sides. What we need is an angle. What is the included angle on this one? Angle L. So, angle L needs to be congruent to something else. What is the included angle between these 2 sides? So, angle L needs to be congruent to angle H. That'd be the answer. All right? These are the last 2. We want angle, side, angle. Figure out what you have and tell me what we do not have.
Just write an angle we don't have.
You name the 2 angles that you don't have or 2 sides that you don't have. Would that be angle, side, angle? That is a segment. Okay, guys. What do we have marked congruent? We have an angle and an angle. What else do we have congruent? A side and a side. So we are not missing a side, right? We are missing an angle. If I say angle V, is that angle, side, angle? No, why not? That would be angle, angle, side. So it would have to be this angle, yes? Okay, so how would I name this angle? Can I call it angle H? I cannot. What would I name it? Angle VHG. And if I wanted angle, side, angle, on the other side I have an angle, a side. What would be my other angle? HGI.